The Let's Encrypt Certificate Authority Service, with its automated certificate installation protocol called ACME, is not designed for private network servers. However, SharkTrust extends Let's Encrypt's capabilities and provides an intelligent solution for using it with any web server technology deployed within a private network. Please refer to the introductory SharkTrust video if you have not already viewed it or are new to public key infrastructure. This video assumes prior knowledge of these concepts. See the video descriptions for links to the introductory information. The source code for the SharkTrust portal can be obtained from GitHub. The repository contains both the code for the online portal and sample code that can be integrated with your local intranet server. A demo portal is available at sharktrust.realtimelogic.com. A SharkTrust portal allows you to manage multiple domains, including registering your own domain for testing purposes. Please refer to the documentation for more information on domain name management. A pre-registered test domain named equip.run is hosted by the SharkTrust demo portal. The provided SharkTrust client examples are configured to use this test domain. To get started, we will clone the SharkTrust repository from GitHub. I will be using both Windows and the Windows subsystem for Linux, so you can see how both environments can be used. The SharkTrust client code can also be integrated with firmware for an embedded device. The console window I am using for cloning the repository runs Linux. The SharkTrust client with the integrated SharkTrust key is an example that registers with the domain equip.run. See the documentation for details on security and the included key for the domain equip.run. A pre-compiled Minnow server Windows executable is also included. This example is pre-integrated with the SharkTrust client, and the source code can also be compiled for embedded devices. We will run both example programs, starting with compiling and running the SharkTrust client with the integrated SharkTrust key. To compile the SharkTrust client, navigate to the SharkTrust example directory and compile the code. Note that the example must be linked with the OpenSSL crypto libraries. When we start the local SharkTrust client, it connects to the online SharkTrust portal using the domain name equip.run. As a new SharkTrust client, it registers with the portal and requests the creation of a private key. The portal then generates a certificate signing request and sends it to the Let's Encrypt service using the ACME protocol. Let's Encrypt then asks the SharkTrust portal to prove domain name ownership by requesting the portal to insert a specific DNS text record under that domain name. This process can take several minutes, and the local SharkTrust client continues to poll the online portal until the portal has received a signed certificate from Let's Encrypt. Once the process is finished, the client downloads the private key and the complete certificate chain. You can view the private key and the certificate signed by Let's Encrypt that were downloaded by the SharkTrust client program. You can use Windows to inspect the complete certificate and its chain. The SharkTrust client has now completed its registration with the online portal. We have to refresh the browser window to see the newly registered SharkTrust client. Please note that the SharkTrust C code example we compiled does not include a web server, thus clicking the link in the portal will fail. However, we can run the pre-compiled Minnow server Windows executable that includes a SharkTrust client and the Minnow server. The Minnow server is a tiny WebSocket server available on GitHub. Reloading the page in the browser will now establish a secure and trusted connection to the local web server. Please refer to the video description for further information about SharkTrust, including links to the GitHub repository and tutorials.